we go. So today we're going to finish up chapter 8, and then we're going to jump in and do chapter 9. Pretty much most of it, actually. We should cover almost all of chapter 9. And then I'm going to have you folks do the Apex Post Survey. We'll take a few minutes in just a minute to do those. Due today, you have Connect Math 8.4 and also Lab 7. You can do that late for full credit until today. Next Tuesday, you have Mindful Math 8.3 and also Lab 8 is due. And then next Thursday, we do not have class next Thursday, but you do have homework due. 9.1 and 9.5 / 9.5, it's one assignment. And then the following Tuesday, you'll have 9.3 and then 9.4 due. Those are kind of shorter, but I do want you to get some practice with those before the exam. Also, don't forget the extra credit for famous mathematician is due. It was technically due Tuesday, but you can turn it into next Tuesday for full credit. So go ahead and get that done. The exam will be Tuesday, May 2nd. Good. All right. So before we get going, what I want to do is hop over real quickly and pop into our assignments. If you go to your assignments, it's either going to be under upcoming assignments or it might be the very, very bottom. Very bottom under depends on how you look at it. But it's this one Apex Post Survey. It's right here. And I do want you folks to, I'm going to give you folks a few minutes. It's basically to give some feedback to San Jose State on this program so they know kind of how it's going and what they might want to change about it. So if you all can hop into your Canvas either on your phone or on the computer on campus, either one, and fill that out. We'll take a few minutes to do that. Yeah. So you can use your W number, that's fine. First and last name. Institution is put LPC, Math 40, and then my name, Young. So those would be the pieces you do there. Later on, someone asked, it is a lab, so if you're not sure how it's presented in class, it's presented as through a lab. So just go ahead and fill those out. Again, institution is LPC, Math 40, and Young. So let's come back and take a look at our what we're doing today. So just to kind of remind people, kind of as we're wrapping up chapter 8, if you reject H0, that means you have enough evidence. So this is sort of the guideline for evidence. Remember, H0 says that you are here. And if I get anywhere in here along kind of if I get in this range, that's kind of typical. The difference between what I get and what I expect to get, this can be totally caused just by random chance. If I get something way out here, then I'm saying that's not due to random chance. That's because my mean is really different than that mean. It's got to be somewhere closer to over here. So that's kind of what we're looking at. And again, this over here is kind of the guilty range. You have enough evidence, you reject H0, they're guilty. Over here, this is the presumed innocent, right? Assuming H0 is true. And over here, there's not enough evidence. Maybe this could be true, right? The differences from what I get could just be due to random chance. So again, step 4, the key part is if you do have enough evidence, then you do reject the null hypothesis. If you do not have enough evidence, then you do not, if you do not reject H0, then you do not have enough evidence. All right, so here are the summaries of steps. Step 1, Austin, go to reforce.
State the hypotheses and identify the claims. Write the claim using greater, less than, equals, or not equals. Write H0, which is always no difference or equals. So P or mu equals P equals or mu equals. Write H1 if H0 is the claim includes equals, then H1 is the opposite. H0 is not the claim, then H1 becomes whatever the claim is. Indicate which one is the claim. If H0 is the claim, then you are doing the test to see if you can reject
Step 2, write down alpha, the significance level. Typically it's 0.5, or 0.5, 0.05, sorry, 5%. But also sometimes it's 10%, 2%, or 1%. Step 3, all right, go ahead.
Find the test statistics Z or T and the p-value. C test or T test is number of standard deviations from mean or samples. P-value is the area beyond your test cap. The probability that the observed difference is due to random chance.
Exactly. So you're going to find your test stat. It's going to be a Z score or a T score. And again, just as a reminder that Z score is how many standard deviations away from the mean you are. Right? And then from there you find a p-value. P-value is the area, is the probability, is kind of the area beyond that. In other words, it's a probability that your sample, the difference between your sample and the mean is just due to a random chance. So if your p-value is really small, then it's really unlikely it's due to random chance. Right? It's more likely that there is a real difference between your population and the general population. Step 3, Maria, go ahead.
Stat test.
T-test,
T-test.
and you just write in mu, x bar.
Yeah. And then the other one is stat test.
Well, read them off. Mu, x bar.
Mu, X bar, standard deviation, and type of test, less, greater, or not equal to. Stat test, 1 prob Z test, P naught, X bar,
X,
Oh,
not x
X.
bar, x.
X, and less or greater than or not equal to. Note the TI doesn't cast what alpha is because alpha has nothing to do with step 3. Just as step 2 only cares about alpha, not your sample.
Right? So step 2 is all about alpha. Step 2 is all about your sample. Step 4 is all about H naught. You're either going to reject it or fail to reject it. To do that, you're going to compare, we're just going to do the p-value method. If the probability of your sample is less than alpha, in other words, if what you got was unusual, then we're going to say, well, it wasn't, just that randomly I got something, it's not just that the difference from my sample to what I expected to get is due to random chance, it's that my sample really is different. So that's when you would reject H naught. And step 5. Step 5 is all about your claim. Step 4, all about H naught, rejecting it or not rejecting it. Step 5, don't mention H naught in step 5. Don't mention your claim in step 4. Step 5 is about your claim. So you're going to summarize the results for your claim. Rafa, go and read.
Step 5, summarize the results. If H naught or H1 the claim, if H naught is the claim, you are testing to see if you have enough evidence to reject the claim. If H1 is the claim, you are testing to see if you have enough evidence to support the claim. Steps 2 to 4 were to see if there was or was not sufficient evidence to reject or support your claim.
Good. And then how does your claim relate to rejecting H naught? So again, if H naught is your claim, then rejecting H naught, right? If my claim is H naught, then rejecting H naught rejects my claim. But if my claim is H1, then rejecting H naught supports my claim. Right? That's why we're going to use the word support when our claim is H1, because it's all about how does rejecting H naught affect your claim. And then we summarize the results. So step 5 is all about summarizing the results. There blank enough evidence to blank the claim that, and you must state the claim in words, right? It's not just, oh, you go home, oh, Mom, by the way, I did this test and I found out that I rejected H naught. They have no idea what that means. Say, I found out that the average weight of cats is greater than the average weight of dogs. Whatever, you have to state, what it is that you found in a way that people can understand and relate to. And then, so you'll lose a point every time you don't state what the claim is. So, it's worth just writing down for that point each time. It's 5 points if there's 5 of them on the exam. And then you have to fill in those pieces. If you reject H naught, then you have enough evidence. If you do not reject H naught, then you do not have enough evidence. So the blue part relies entirely upon step 4. This red part relies entirely upon step 1. Which one is your claim? If H naught's your claim, then rejecting H naught rejects your claim. You're going to use the word reject there. If H1 is your claim, rejecting H naught supports your claim, so you're going to use the word support there. Also, don't forget in step 4, these are just some quick reminders. In step 4, make sure that you actually say, don't just compare p-value to alpha. If you don't say whether or not you reject H naught, that's 2.5 points every single time. That adds up. It's more than 10% of your exam. Because you have to say, well, not only do you do comparison, but what does that mean? Because remember, it's a hypothesis test to either reject or not reject H naught. You have to actually do that. If you don't write down H naught and you say reject, you have to say reject what? If you don't say, tell me what you're rejecting, if you don't write down the actual, literally write down H naught, then you lose a point the first time and then half a point every other problem after that. So that adds up a few points as well. So make sure that you include all of that. I also would like you to show me. You don't have to write down the formulas. You don't have to draw a picture. Instead, I want you to show your work by writing down which test you used and what you put into the test. Okay, that's showing your work. I need that. Good. So those are the 5 steps, which I believe you're all familiar with. So quiz problem number 1. And again, you should be able to do this entirely using your half-page of notes. At this point. If not, then you should be creating your half-page notes and adding stuff into it. So take a look. So this problem, is this a proportion or a mean?
Mean.
It's a mean. How do we know?
Average.
It says average. Also, my data is numbers. Anytime your data is numerical, that leads to a mean. So sometimes it may not say mean or average, but it'll give you a list of numbers. That's your clue that it's really a mean in disguise. So here you're going to put this into list 1, and then you're going to do stat, test, t-test, and you're going to put in data, not statistics. And then it's going to know where to grab this. So what we'll do is this. Put this into list 1. And then on your calculator function, you're going to go to stat, test, t-test. And instead of statistics, you're going to do data. You put in your mu naught. What's my mu naught?
515.
515. And then you're going to put in list 1. You only want one of them, so leave the frequency at 1. You only want to use that list once. And then you put in your claim like you would normally do, your H1. So here, first off, we have to figure out what the claim is. So find the question mark. Claim, support, evidence, that's all tells me what the claim is. So kind of running away. She wishes to see if her students wishes, that's sort of the same thing, if her students scored below the national average. So she's saying that her claim is that their mean is what?
Less than
Less than. Below the national average, and the national average, like Jason said, is
515.
515. And then the sample, she does randomly sample 12 students, so I should make this the color, and they are here below, as shown, right? So this is my data, and again, I said you're going to put that into list 1. So your step 1 is going to be your H naught, which is always, always, always equals, in this case, your mean equals 515. Whatever is in your claim, that is your mu naught. So this number stays throughout everything else, and it's your mu naught. Your claim is your mu naught for your, in terms of your calculator function, this number right here, the mu naught. That's the number in your claim. People struggle with that a little bit. That is not my claim. My claim is less than. So H1 becomes my claim. I'm going to write the word claim next to it. And in parentheses, I'm going to write which one? Reject or support?
Support.
Support. Good. Step 2. Alpha is 0.01. Right? Yeah, 0.01.
Yep.
Good. Step 3. I'm going to do a t-test. And again, I'm going to use data on the t-test. I'll put data. So you recognize it's not the regular t-test, it's the other one. And inside we're going to put in my mu naught, which is 515, L1, one of them, and less than. I think that's it, right? And calculate. What'd you all get for your t value? Anyone? You still not get this yet?
0.356.
0.356. And what'd you get for your p value?
0.6336.
63.636.
Six.
Good. Is that what everyone else got? Yes, no?
Wait, it's supposed to be 3 decimals or 4 for
4, ideally 4.
that? Okay.
Shirley, did you do 4?
Yeah, 6359.
1?
59.
5-9? Okay, good. So then, step 4, I'm going to compare my p-value. 6359. It's way bigger than alpha. Why is it bigger than alpha? What? Let's see how huge it is. 63.59%. This is why. Here's my normal distribution. She's saying that she's worried that hers are in this bottom 1%. Is everybody with me on that one?
Yes.
Here's 515. Not only were they not in the bottom 5%, they were above the mean. Her average was like 523 over here, way over here. Totally not below the mean. Does everyone follow? She's worried they're below, and not only are they not below, they're above. So there's 63% of the data is below them. So they're way not below the mean. Okay. That's why that p-value is so huge. All right, so here, am I going to reject H naught or not reject H naught? Yeah, not fail to reject H naught. Again, remember, you never accept H naught. You either reject it or fail to reject it. Here we're going to fail to reject it. We're not going to reject it, which means that there is not enough evidence. To support, from step 1, the claim. What is my claim? That her students scored below the national average. And again, the not comes straight from that not, and support comes from that first step. Okay, everyone feeling all right with this part? Yeah.
Wait, for step 4, you put not reject, you don't put fail to reject?
You can do either one.
And then for
Not
step,
reject is the same thing as failing to reject.
And then, but for step 5, you just put not enough instead of
Yeah.
fail.
So what I like about doing not reject is then the not goes, if there's a not there, there's a not there. That's what I like about the not.
Okay.
Yeah.
I was just wondering for
Is it makes that easier. Fail to reject is the same thing as not rejecting. Yeah. If I do not reject you, that means I failed to reject you. But like I said, the great thing about having the not there is then I can just grab it and throw it right in there, so they match up.
That's good to know.
Yeah.
Thank
Yeah.
you. Is that your question too?
No, let's do this.
Oh.
All right. So then we have quiz problems 2 through 4. Aha. Okay. So. Do you folks want a minute to think about these with your neighbors? As p-value gets smaller, what happens to the strength of evidence against the hypothesis? Smaller p-value means what?
Less strong.
Let's try.
So p-value of 0.000000001 means what about the null hypothesis? Again, is that strong evidence against it or weak evidence against it?
Oh, strong.
Strong evidence against it.
Oh,
Right? The smaller my p-value, it means I should totally reject the null hypothesis. It's really unlikely. Remember we did last one when we had 14 out of 16 infants? That was like 1 out of 1,000 times that should happen. That's really strong evidence that those infants are not picking randomly. Right? So the smaller your p-value, the p-value is the probability of randomly getting a sample like yours. It means the probability that the difference between what you got and the null hypothesis is just due to random chance. So if the difference between what you got and the null hypothesis is really, really tiny, like 1 in a million, that means that's probably not due to random chance. Instead, it's due to the fact that you really are different from the null hypothesis. So small p-value means really strong evidence. So the next question is, if all else remains the same, a smaller sample size has what effect upon the width of a confidence interval? This one's a little bit trickier, so I would suggest we look at this. Confidence interval. Confidence interval is what you got from your sample plus or minus the error. What's the error? So if you all recall, right, here's my p-hat. I subtract my error to get to my lower limit. I add my error to get to my upper limit. That's my confidence interval. So the bigger my error, the bigger my confidence interval. Right? Because I'm subtracting my error to get to my lower limit. I'm adding my error to get to the upper limit. The bigger my error, the bigger my interval. The smaller my error, the smaller my interval. Is everyone kind of following me? So what's the error made out of? The error is made up of this. For proportion, for example, it's the critical value, which we cannot control at all, that's fixed, times the square root of p hat q hat, which again we cannot control, divided by n. So only thing that varies in here is n. We're dividing by the square root of n. So you have to think about, what does dividing by the square root of n do? What does that do? So let's look at this. I got 20 bucks. I divide by 4 people. How much do they each get? $5, great. Now I'm going to divide by a larger number. 20 bucks and divide amongst 10 people. How much do they each get?
$2.
2, they get less. The more people you divide by, the bigger number you divide by, the less you have. The smaller your result. So the bigger my n is, the smaller my result. So why don't you folks take a second with your neighbors and figure out, based upon that, how are you going to answer problem number 3? So, smaller sample. If the sample's smaller, what happens to my error?
Gets bigger.
Gets bigger. Okay, so the smaller the sample, the bigger my error. If all else changes the same, a smaller sample will have a bigger error. So a bigger error, what does that do to my confidence interval?
Wider.
Becomes wider. Does that make sense for folks? Which sort of makes sense because remember before we want our error to be within a certain number. We want our error to be kind of small. We had to pick how many people we had to ask. How large should our n be in order to get a small enough error? So the larger your n, the smaller your error. Which kind of makes sense because you think about it. The more people you ask, the smaller your error should be. Does that sort of make sense for folks? And the more people I ask, if I ask everybody in the whole world, my error should be nothing, right? If I ask everybody. So the more people you ask, the smaller your error becomes. So here, the flip of that, the fewer people you ask, the larger your error should become. Okay? And the larger your error becomes, the larger your confidence interval. So you have to think through a couple pieces there. But if you have a smaller sample size, you have a bigger error, which means that your confidence interval is going to become wider. Last one. The null hypothesis is not rejected at the 0.01 significance level. Would you reject null hypothesis at the 0.025 significance level? Do you folks want 30 seconds to talk about this with your neighbors? Yeah, take 30 seconds.
I put the last one.
If you aren't sure, alpha is the significance level. So this is alpha. Significance level and alpha are the same thing.
Yeah, but that's not.
I was about to say, like, wouldn't you know